Hey guys, welcome to lesson 4, and we are going to be talking about when you have radicals, what to do when you are dividing them. So I just want to start off with some problems. Do not make it more difficult for yourself than it has to be. So what I'm saying is you could do a couple different things with this one. You could see that you could take the square root of that, which is 3, or you could look at it as 63 divided by 9, which is the square root of 7. So however you want to look at it, it's fine. Just try to make it as easy as possible on yourself because these get pretty yucky. And just look for ways to help it be a little bit easier. So for this one, what I would do is I would kind of do the same thing that I did over here, and I would just kind of combine them because I could see where we could simplify it. So, well, let me just write it out this way. So then I'm going to have 32 divided by 2. That's 16. And then a to the 11th over a to the 3rd. That's going to be a 8th. Okay. And so now we're just going to simplify this like we've done before. So I can take the 4th root of 16. The 4th root of 16 is 2. And then I'm going to ask myself, how many times does 4 go into 8? And it goes into 8 evenly 2 times. And so an a squared is going to come out, and nothing is going to be on the inside because I have no remainders here, and this comes out perfectly. So my answer is 2a squared. So see if you can do this one. Okay, so the first thing I did is I just simplified 128 divided by 2, and then x to the 10th over x squared, and that's where that step comes in. So now I'm just simplifying it. So I split up that 64 because I can take the 5th root of 32, that comes out as a 2, and 5 goes into 8 one time, so I'm going to have an x to the first come out, and I have 3 x's left over on the inside. So that's my final answer there. Okay, sometimes you won't see it in fraction form. Sometimes you'll see it like this. So I have 2 divided by 3. So think about the same thing here. I can rewrite it as 27a to the 3rd over 9a squared and just kind of have it turn into a problem like this up here. Oops, sorry, this is 27. And then just simplify it. So this ends up being 3a and the square root of that. Okay, let's keep going. So we're just talking about different things that you'll encounter. So this is actually like just distributing the exponent. So know that you need to do the exponent both pieces of this. So we have a 5 and a cubed root of 2. And I'm going to show you why. Let me write this out. So never get away from the fact that this like expanded is what this means. And so notice that I would take each one of these and multiply it. So that's going to be 125. And then I have the cubed root of 2, and I'm taking that 3 times. This times this times this. So I'm taking that to the 3rd power. So what happens is the cubed root to the 3rd power, those cancel out to 1. So I have 125 times 2 to the 1st, or times 2, which is 250. So try the other 2 and see what you can do. Okay, so there's a couple different ways to look at these types of problems. So if obviously this part is easy, you're just going to take 2 to the 4th power. But this part right here, there's a couple different ways to look at it, and just whatever's easiest for you. So I showed you one way in this problem, and I showed you another way in this problem. So if you want to look at this as like there's 4 3's that are being multiplied together. So if you take the cubed root, you're taking 3 of those, a group of 3 of those, and those come out as 1. So I'm left with 3 cubed root of that 3 on the inside. That sometimes confuses some people, and so once you have that 3 on the outside, you're just going to take that 16 times 3 and leave that alone. Over here, I kind of tried a different approach. So what you could do is, like on this one, you could have just taken this 3 to the 4th and turn it into an 81 and then just simplify it. So that's what I did here. So this 4 squared, I just turned it into 16 and then I just simplified it from there. And I ended up getting 2 cubed root of 2. So when that 2 came out, I was able to multiply it to the 5 squared and get 50 cubed root of 2. Okay, now we're going to go back into the dividing part of it. So you have to rationalize the denominator. So what this means is that you cannot have a radical in the denominator. And you guys, this is nothing new. So we're just going to kind of review this. So when you have a square root, it's pretty straightforward. And this is like probably where your comfort level is. So you just multiply the top and the bottom. And so what happens on the bottom is when you multiply those together, it becomes the square root of 4. And the square root of 4 is 2. So then it becomes, then it becomes a nice number. And that's your answer. When you get to a problem like this, it becomes a little bit more complicated. So think about, I need to make this 2. So I have, so I have 1, 2 here, but I need a group of 3 2s. So let me show you this. I need a group of 3 2s to come out as a normal 2. So that's the way I look at it. So if I have 1, 2 here, then I'm going to multiply by 2 of the remaining 2s here to get to that cubed root of 8, which is 2. So that's my goal. Okay, so I'm going to multiply both the top and the bottom by that set of 2 2s. So I have 3 cubed root of 4 over 2 on top. Okay, so go ahead and try this one. This one is the same way. Okay, so there's a couple different ways to do this. So I want to, if you just took it as is, you had to multiply it by the 2 4s to get the 4 to come out. The problem with this is it always has to be simplified. And so you could break up that 16 into 8 and 2, and the cubed root of 8 is 2. So that's where this is coming in. And so so then you can either multiply this and you get 6 4s, which simplifies to 3 halves, or you can simplify this. It doesn't matter. But your final answer, you just have to do a lot of steps. So I want to show you another way to look at it. So notice that this is 2 groups of 2. So I just need 1 more 2 to get to that the 2 to the 3rd power. So then I can just have it be 2. So you'll become better at seeing this, but try to make it as like, to me, I think this is a lot easier than doing it this way. But some people just need to do those extra steps, and that's okay. Notice we ended up in the same spot. It just takes more steps. So what I would do is I would see if I could simplify that at all. So go ahead and try that. Okay, so notice that this is the same thing as 2 to the 9th power. So it doesn't always have to be like a first power. Like, so if I added, let's kind of play around with this. If I added 1 more 2 to that, so I'm going to multiply them together, I would get the 5th root of 2 to the 10th power. And 5 goes into 10 evenly 2 times, so it'd be 2 squared. And so that is totally okay too. So instead of having my goal be 2 here, I'm going to have my goal be 4. And so we're going to treat this a little bit differently. Okay, so again, I'm going to, I'll erase this through here. So this is the 5th root of 2 to the 9th power. Okay, so remember, I need 1 more 5th root of 2, and that's going to give me that fifth root of 2 to the 10th power, which is 2 squared. So it tells me what I need to multiply the top by. So my final answer is 5 times the fifth root of 2 over 4. Okay, so now we're going to incorporate some variables into this. So the first thing I'm going to do is just split it up. And remember, your goal is groups of whatever this is. So it's going to be in groups of 3. So I have 1, 2 here. So I need 2 2s. I have 2 b's here. So I just need 1 more b. And so I'm going to multiply both the top and bottom by the cubed root of 4b. Okay, so notice they're both underneath the cubed root. So I'm going to have the cubed root of 20b on top. And then on bottom, let's look at this. I have 2 to the third power, b to the third power. So that simplifies out to 2b. And that's my answer. So see what you can do with this one. Okay, so this problem is a bit of a doozy. So the first thing that I noticed is that I could simplify this. So I went over here and I simplified it, and I got 3b times the fourth root of b. So that's where this is coming into play. I also noticed that I had a group of 3 b's here, and I needed to get to 4. So that's why I multiplied by that b to the first. Okay, now we are not done. So the first thing I notice is that these b's can cancel out. Something else that's bugging me is that I know I can simplify this. So I want to show you what's going through my mind. So I have 3b to the, I'm going to write it in exponential form to show you this, to the 2 fourths power. So I don't know if you guys can see it now, but you can simplify 2 fourths. So I have 3b to the 1/2 power, or 3 times the square root of b.